right? So the three main ones, three main functions. We have sine theta, cos theta, tan theta. So for those who learned sec, cosec, and cot, no longer on the syllabus, so don't worry, right? So they only use sine, cosine, and tangent, right? So those who learn sec, cosec, and cot, not on the syllabus. Right. So the first thing we learn is the quadrants, right? So every trig result has two values, right? So just remember -1 less than or equal to sine theta less than or equal to 1. -1 less than or equal to cos theta less than or equal to 1. And minus infinity less than or equal to tan theta less than or equal to infinity. So that means that sine and cos is only between 1 and -1, where tan could go to any value, right? So for example, sine theta equals 2 has no solutions, right? Because it is not between 1 and -1. All right. Now the quadrants. So you write them like this: A, S, T, C. This is quadrant 1, 2, 3, 4. So quadrant 1 is T 0 to 90 degrees, or 0 to pi over 2 radians. All angles are positive. Right, and theta is equal to theta r. Quadrant 2 is 90 to 180, or pi over 2 to pi. Sine is positive, cos and tan are negative, and theta is 180 minus theta r, or pi minus theta r. Yeah, I'm going to post this class, don't worry, right? So I'll just give you all, and let's take it down if you want. Remember, I'm recording it, so you don't have to, but
Afternoon, sir.
good afternoon, Mr. Otley, all is well?
Yes, sir, I got.
Okay. All right. So we have quadrant 3, which is 180 degrees to 270 degrees, or pi to, I should put an arrow here now. I'll make it an arrow, right? Just in case. Remember in class 2, you also thought it was a minus, right? So 3 pi over 2 tan is positive, sine and cos are negative. So theta is 180 plus theta r, or pi plus theta r. And finally, we have quadrant 4, which is 270 to 360, or 3 pi over 2 pi. Cos is positive, sine and tan are negative, and theta is 360 minus theta r, or 2 pi minus theta r. Right, so the steps, I'll write the steps here. 1, identify which quadrants based on the sign, so whether it is positive or negative. 2, find theta r, which is the acute or positive angle. Now, I use the word acute because I know Mr. Romeo taught it as the acute angle, right? So that's just for students in her class as well, right? I usually say theta r is a positive angle, so no matter what, it will always be positive, right? 3, use formulae to solve, right? Per quadrant. All right. So I'll do the identities next. I'll tell you the ones you have to know, and then, oh, all right, cool, no problem. We have a minute to do. All right. I'll tell you the ones you all need to know, and then the ones that you could kind of get away with, and the ones that are given for sure. All right. So the next one. So now the trig identities. So here are the need to know ones. Sine theta, sine squared theta plus cos squared theta is 1. That's the one you need to know. You always, well, highlight the ones you need to know, right? Sine squared plus cos squared is 1. And 2, sine theta over cos theta tan theta. Right? For sure, you need to know these two. Though these two aren't given, you need to know them. All right? Um, 3 sine of A plus or minus B is sine A cos B plus or minus cos A sine B. Right, they give you it. So reason why I write it like this is because this is how they give you it in the
And sir, I have a question about it. When
mhm,
you use like, let's say for example, sine A plus B,
mhm.
isn't it then sine A cos B minus cos A sine B, or is it
No.
both plus?
So what happens? Very good question, right? So when they give it in this in the exam, you don't know what to do. The sign on top here matches with this sign here. Likewise, the sign below here matches with the sign below here. So if it's A plus B, then it's sine A cos B plus cos A sine B. If it's A minus B, then it's sine A cos B minus cos A sine B.
All right, sure, thank you.
Yeah, very good question. I'm glad Otley brought this up as well because I know it can be a bit confusing within the actual formula sheet because I know you're all accustomed to seeing it separately. Right. The third one, sorry, the fourth one, cos A plus or minus B is, yeah, the class will be posted after. Should be cos A cos B minus or plus sine A sine B. So this is what Otto was talking about, right? When it matches up. So you see how the minus here matches with the minus below. And the addition matches up with the addition, the minus on top. So this is the one where it gets a bit tricky, but yeah. This one, right? This one, I tend to write it. It's not an official identity, quote unquote. However, I think it still needs to be said. Actually, no, let me do tan first. Tan of A plus or minus B is tan A plus or minus tan B over 1 minus or plus tan A and B. So the plus matches up with the plus, matches up with the minus, and the minus matches up with the minus, matches up with the plus.
So that tan formula does come on the formula sheet.
Yes, correct, it does.
So sir, let me say they give you a question with like tan A plus B. It would make more
Mhm.
sense to break it out with that formula rather than converting it to sine over cos.
Correct. Right. So this is the one I was talking about, right? So sometimes it's hard to remember if to do it or not. I need you to remember sine squared theta is the same as sine theta all squared, right? And this works for cos and tan, right? So it also works for cos and tan. Yeah. So sometimes you all tend to forget that sine squared is the same as sine theta all squared, right? Don't forget that, right? That is the main component there. All right, another one. So these are the double angle formulae. 7. Sine 2 theta is 2 sine theta cos theta. 8. Cos 2 theta is cos squared theta minus sine squared theta. Now this is also equal to 2 cos squared theta minus 1 or 1 minus 2 sine squared theta. How I got that? Just use sine squared theta, 1 minus cos squared theta, and use cos squared theta, 1 minus sine squared theta.
Sorry, can you just zoom out so I can take a big screenshot of all of them, please?
Just want to do one more and then I'll do it, right?
All right,
I'll
okay,
do the
cool.
tan 2 theta.
All right.
So we have the tan 2 theta, 2 tan theta, or 1 minus tan squared theta. I want you to note here as well, note well, we can find the double angle formulae using A plus B, as 2 theta is the same as theta plus theta. Right. So what do I mean by that, right? So they just give you the sine A plus B, cos A plus B, tan A plus B, right? They don't give you the sine 2 theta, cos 2 theta, tan 2 theta. However, you could derive it, right? So yeah, so for those who want to take a screenshot, right? You could derive it using what they give you. So for example, 2 theta is the same as theta plus theta. If I were to put it in here, sine A cos B plus cos A sine B, I would get sine theta cos theta plus cos theta sine theta, which is 2 sine theta cos theta. You can get that, right? So always be looking out for that. Remember, the goal is to work smart, not necessarily work hard. You don't want to bust up your brain trying to remember all these formulas when they're giving you the majority of it there. Right? Now, again, some of you all have learned all the formulas, and that's good. Whatever works for you at this point. Now, with this in mind, right? I want to give you all a question to try now. Right? Now, with respect to proofs, one, start on the side with terms to break down. Two, break down into sine or cos. If possible, rearrange. Now I want you all to note something here, just quickly note well, we cannot move across the equal sign, right? We can only use one side or the other. All right, so take a picture of this. I'll give you all a couple of minutes, and then I want to look at the past papers now, right? So we're going to do 2022 all the way back to 2017.
Like the whole thing, right?
No. Just the trick questions, right?
All right, okay.
I have a question. I think I saw that they
Mhm.
didn't bring logs, I think last year or something. So
Yeah, most likely they would, right?
they would bring logs this year. That's what I was gonna ask.
Yeah.
Yeah.
Right. So let's look at the 2022 paper, right? These two questions here. All right, so this was 6 marks. Show that cos 2 theta is that, and hence solve the equation. Right. So they say show that, right? So you can't just say, oh, well, cos 2 theta is that, right? So that's why I'm saying with the proof, you have to show that it's theta plus theta. A lot of people got this question wrong in last year's paper because they just say, oh, well, cos 2 theta, that's the identity. Whenever they say show or prove, you have to use the theta plus theta, right? Right, so you go cos 2 theta is cos of theta plus theta, which is cos theta minus sine theta cos squared theta minus sine squared theta, which is cos squared theta minus 1 minus cos squared theta minus 1 plus cos squared theta 2 cos squared theta minus 1. Right, now just quickly I'll show you all one time. Right, so these are the three you get in your formula sheet. As I see it there now, anybody get a vectors question wrong in this ADMAS exam, I will triple, because they give you the unit vector, right? Well, this wrong here. This is supposed to be, they would give it correctly, right? They give
Sir,
you,
isn't the circle equation wrong as well? Isn't it minus?
right, so they give you a different circle equation, right? They just give you that one to tie up your head, right? The one you know is x minus a squared plus y minus b squared is r squared, yeah? And they give you how to find that. So with vectors, please just do one vector question. Make sure you know when to use the formula, and then, yeah. Right, so let me go back to this question. So yeah, very good. Again, Otley, bring it up, right? That, to use that circle formula, please, right? Use the one you're accustomed using. Right. So now we go to cos 2 theta. Now they say hence, right? Anytime you see the word hence or thus or so on, you have to use the result from before to solve it. Cos 2 theta plus cos theta plus 1 equals 0. So we use that 2 cos squared theta minus 1 plus cos theta plus 1 equal to 0. We get 2 cos squared theta plus cos theta equal to 0. Factor cos theta to 2 cos theta plus 1 equal to 0. Find this hard for 2 marks, boy. Hard, boy. That's a hard 2 marks there.
Sir, isn't it a disguised quadratic?
Yes or no? Yes, it is a disguised quadratic. You don't have to go through that route because of how C is no longer there.
All right.
So I get cos theta is 0. 2 cos theta plus 1 equal to 0. So here's a bit of a weird one, right? You treat 0 as positive or negative. So cos is positive in all school teachers' curves. We know the other one. Already know the other one. Let's just leave it at that. It's better left unsaid, right? Cos is positive in first and the fourth quadrant. So cos of theta r is 0. Theta r is cos inverse of 0, which is pi over 2. So theta r, being in the first and the fourth quadrant, would be theta r 2 pi minus theta r. So we get, what is that? Pi over 2 and 3 pi over 2. Then the next one now, cos theta is minus a half. So cos is negative in the second and the third quadrant. Cos of theta r is a half. So this is what I'm talking about. Theta r is the acute angle, so you make it positive, right? So theta r is cos inverse of a half, which is pi over 3. So therefore, theta being in the second or in the third quadrant is 1/8, say 1/8, yes. Pi minus theta r, pi plus theta r, which is 2 pi over 3 and 4 pi over 3. Right? So two things I want you to note. One, I look at the range they gave me, and I know I have to work in radians. Two, you're going to get two answers, right? Two sets of answers. Therefore, you have to do all four quadrants. Well, not four quadrants, but all four answers. Three, if you were to happen to get 2 pi or 0, those are not viable answers because it's strictly less than and strictly greater than. Right? So hopefully you all got this one. So this is the most recent paper. Therefore, you should get an idea of the most recent working, right?
So what happens when you leave theta as like negative instead of switching it to positive?
You lose a mark at most, right? But you should switch it to positive. If you leave it in negative, some of the calculators get a bit weird when finding the inverse. Yeah? So that's what happens, and you end up getting the wrong value.
So then theta r is always positive.
Yes, correct. So if theta is a minus a half, then theta r would be a half. All right, so I have an idea there. Now, before I go on, I realize I forgot something with regards to trigs, and that is exact values. All right, now, back when I was a wee lad, back when there were days when things was rough, right? Back in my day, we didn't have the thing we call the Casio calculator that didn't return the answers in surds. You used to have to learn these off. Now you all have your nice little Casio calculator and everything nice, life nice, right? So this is theta, sine theta, cos theta, tan theta, and we have 30 degrees, pi over 6, 45 degrees, pi over 2, 60 degrees, pi over 3, 90 degrees. Oh, yeah, thank you. Pi over 2. right? So as I said, back in the day, we didn't have the calculators that would return the value in third form. So you just have to learn it off, right? But now you'll do root 2 over 2, 1 over root 2, 2 over 2, 1 over root 2, 1, 3 over
Where's the
2.
inert form? In third form.
How do you what?
Get it in third form. 'Cause
You mean
I get a decimal all the time.
right? So so that's what I say. Some
Okay,
cats
calculator not bad, boy.
if you have
Wait, in radians, boy.
no, even so
But I
some of
do
the
that.
even some of the calculators don't return that root value. So that is where you need to know these values, right? So that's the only issue there. So if you don't have that calculator, then no, right? 1 0 undefined. But there's an easy way to learn it off, right? If you're not getting it in thirds, that is fine. It happens. This is what the table is for. But there's a triangle you learn off, right? Just learn off this triangle here. If this is 30 degrees, this is 60 degrees, right? Likewise, if this is 45 degrees, this will obviously also have to be 45 degrees. Now, what is sine 30? Sine, so remember sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So we know cos sine of 30 opposite over hypotenuse is 1 and 2, right? So then this side must be root 3. Right? And for a isosceles triangle, these two sides must be the same. So this is 1, 1, root 2. Right? So just learn off those two triangles. So if like in the exam, you could just learn off these two triangles. Now the next thing too, how did I get root 2 over 2 is 1 over root 2, right? What's the difference? Root 2 over 2 is the same as root 2 over square root of 2 by the square root of 2. That cancels with that. 1 over root 2. You could get either form, right? So yeah. All right. So let's do the other question now. So I'm going to 2021 now to see what trick question they brought. Now after this we'll do logs, right? Logs and the C-seeds. Oh wait, this one up, sorry. All right, so this one gave a lot of people trouble. But I want to see how y'all would approach a question like this before, right? So the same thing I was doing, right? What is cos? Cos is something over something.
Yeah, adjacent over hypotenuse.
Yeah.
So your adjacent is 24 and your hypotenuse is 25.
Right. So
Sure, you want us to like explain how we would approach it still or not?
No. So find the answer. Do the answer for me.
Oh, the whole thing?
Yeah.
Alright.
So I see this question before,
Mhm.
and I actually genuinely couldn't believe this was our marks. I thought this was normal marks.
Yeah. So
You're cool.
the thing is too, right? You could find the inverse as well. Like, I don't know, you could. They don't really business too much. They left it pretty open ended.
I would have just think about it like a right angle triangle and root for like
Yeah.
opposite over adjacent and just plug in for my double angle thing.
Correct. You could do that as well. But actually, that's what you're supposed to do. Yeah, you're supposed to get a big number. All right. So it's correctly stated. This is M, right? We would have M is opposite over adjacent, 24 over 25. So how would we find hypotenuse? Hypotenuse. Oh, wait, no, sorry. Cos is adjacent over hypotenuse, 24, 25. So that means the opposite side is the square root 25 squared minus 24 squared, Pythagoras theorem, which is square root of 49, which is 7. Now, the 7, 24, 25 is also a known triangle, right? But if you don't do it, fine, right? So tan M is opposite over adjacent, which is 7 over 24. So I would get now tan 2M is tan squared M over, sorry, 2 tan M Russian question, over 1 minus tan squared m. So we'd get 2 by 7 over 24 over 1 minus 7 over 24 squared. So you get 7 over 12 over 1 minus 49 over 576, which is 7 over 12 over 527 over 576, which is 7 over 12 multiplied by, when you divide by fractions, you flip it, 576 over 527, flip it and multiply, and you will get 336 over 527. Because this into this is 48. Yeah. 336 over 527. You all got that?
Sure, I just have one question, sir.
Mhm.
Could you have used like tan M plus tan M and then one minus tan M?
Yeah,
But
yeah.
that's okay.
You get the same thing. So
All right,
what you're
okay.
saying is
Like,
doing tan m plus m.
Yeah, I just don't understand it this way.
Yeah, that's fine.
This is the question.
So you're
Mhm.
telling me if I did m equals the cos inverse of 24 over 25, multiply that by 2, and I put it into my tan, get the
Yeah.
same answer, and not
Yes.
losing any marks?
Personally, no, because they didn't give you any restrictions. So no, you would get correct.
Yeah, because all I did was do the cost inverse and plug it into the term, and I get the same answer you get. So
Yeah, that's fine. Because so in the older papers, they'll give you a restriction, right? But with now, you'll be able to do it. You can use quadrant in this case as well because they define the angle as acute. But yeah.
So what would the restriction look like? Do you know, just for
So
no
they'll give you obtuse angle. So if it's obtuse, right? Let me just say sine x, I'm just saying, right? Let's say sine x is 12 over 13 and x is obtuse, right? You would draw the triangle like this, x, 12, 13, right? But this would be minus 5 because if x is obtuse, cos x must be negative. Remember, it's in quadrant 2. If it's obtuse, any angle obtuse is between 90 and 180. So cos x would be minus 5 over 13. And tan x would be 12 over minus 5. Yeah?
So I don't understand that, to be honest with you.
Yeah, that's fine. All right, so I'm going to be honest here, right? So at this point, and this is the reality, right? If you don't understand it now, chances are by the time the exam come around, you're not going to understand it fully. So what you need to do is stick to your strengths at this point and build on your weaknesses a bit, but don't try to teach over anything to yourself or teach yourself anything new, right? Because if you do that, you'll end up confusing yourself. So like, if you don't understand this, do business with it. Approach the question how you could, and you may not get the full 4 marks, but you could get 2 or 3. But don't ever leave a question blank, right? But that's a restriction. And they stop, from what I've seen in recent papers, they stopped giving that restriction. But in the event that they might give it, some of you all would get the full 4 marks, some of you all would get 2 out of 4, and so on. Right? That's just the reality of it. All right. Take a picture if you have to. I want to do the 2019 paper now. right. So try 2019. Don't worry, probability covered that, so don't feel like we're not gonna touch on probability and anything as well. All right, so you see this question has become sort of a trend, right? So try these two here. All right. So I'll be back. Just give me a second. All right. Well, give me like a minute. Let me get my calculator. I just use my phone calculator.
Future question. So for something like this, and they say without evaluating theta, right? If they see on the paper that like you work out theta, they would just not mark the question at all. You wouldn't get any marks.
Well, I think they said without evaluating theta, so I believe so.
You say you come back, you know.
All right. So let's go. So we'll get, so we go triangle here. Theta root 5, 5. So therefore this side, 5 squared minus root 5 squared, the square root of that is root 20, right? Now that exact third form is a issue, big issue, right? What you have to do, split it into thirds, 4 times 5, which is root 4, root 5, 2 root 5. So if I didn't do that, would I lose marks? Not tough one. You might lose half mark if necessary. They say it in third form. They never say the lowest third form. So if you leave it as root 20, if they said the lowest third form, you'd lose marks. But because it just said in third form, if applicable, I don't think you'll lose marks. It's very weird about the wording. So this is 2 root 5. So we will get cos theta is adjacent over hypotenuse, which is 2 root 5 over 5. Now some of you may have put 2 over root 5. 2 root 5 over 5 is accepted. So how did you get 2 over root 5? It is 2 root 5 by root 5, 5, 2 over root 5. Again, this is accepted. I'm only showing the other way just in case someone worked it like that. Right? Just in case. Sine 2 theta is 2, or let's write it out then. Sine theta cos theta plus cos theta sine theta, which is root 5 over 5 by 2 root 5 over 5 plus 2 root 5 over 5 by root 5 over 5, which becomes 2 by 5 over 25 plus 2 by 5 over 25, which is 20 over 25 or 4 over 5. Right?
See, that part, okay. That part in our work out there with the sine theta, cos theta, plus cos theta, sine theta, right?
Yeah, but
That's for the second part, right?
yeah,
Or the
that's for
first-
this one here. I just didn't
Oh.
want to scroll down, right?
Oh, yeah, I want to.
Yeah. Yeah,
Nice.
don't worry. Yeah.
So let me tell you what I did, right? So I see the sine theta equals to 5 over 2. I multiply that by 2, got an answer in my calculator, and then squared it and got 4 over 5. I could do that.
Oh, so you big brain the situation. So yeah, you could do that.
Very cool.
All right. Give you all a minute to take this again and then we'll do another one.
Sir,
Yeah, you can use the double angle for me. Yeah, please talk to me.
2 root 5 is an answer, right? 2
Yeah.
over. Is
2
that
over
the
root.
same- is that the same as 2 root 5 over 5?
Correct. Oh yeah,
Okay,
you got you lagged out. Yeah. So I'm saying
Yeah.
you could use either one.
So 2 root 5 over 5 is applicable, right? requirement.
Yes.
Okay, cool.
Correct. Right. So the last one I'll touch on is 2018. Now, just want you to know, I'm only stopping after 2018 in restrictions of time. Your job is to go 2016, go back. Right? So
So where to get them fast pass?
St. Hill works, this one.
Still Hill.
St.
All right, okay, cool.
Yeah. I decided I'll just be showing you all. All right. So look at the 2018 people, and then we'll do some logs, indices, and series. All right, so we'll do this one, and then we'll do the proof as well, right? So obviously, you're gonna have to change something, right? Okay, that's the most obvious statement I could have made, right? You choose what you're changing. Also pay attention to that range, yeah? So We're dealing with sine squared. Could we change sine squared in terms of cos 2 theta? No. Could we change cos 2 theta in terms of sine squared? Yes. So we get sine squared theta plus 3 into 1 minus 2 sine squared theta is 2. So we get sine squared theta plus 3 minus 6 sine squared theta minus 2 equals to 0. So we get minus 5 sine squared theta plus 1 equals to 0. So we'll get sine squared theta is 1 over 5. All right, so why we can't change it to cos? Okay, so if you want to take the long route, you could go 1 minus cos squared theta plus 3 into 2 cos squared theta minus 1. By all means, right? However, this is the easier of the two because it only requires one thing you need to change. As opposed to having to change two things.
Sir,
Yeah.
the cos 2 theta, how come essentially you could have done a cos A plus cos B, but that's the longer way, but we just use the cos square theta minus sine square theta.
Right, so yes, you could use that. So, okay, so you'll go cos sine squared theta plus 3 into cos squared theta minus sine squared theta is equal to 2. And then you could change sine squared theta plus 3.
That cos square theta into 1 minus sine square theta.
Right.
Minus sine. But
Okay.
where do you get the 1 minus 2 sine square theta from? That's what I just want to know.
Oh, because when I reduce this, sine squared theta plus 3, 1 minus sine squared is minus 2 sine squared theta. Yeah?
All right. Okay, cool. Oh,
Yeah.
you just did it in your head.
Yeah.
All right, okay. All right.
Right. So sine squared theta minus 5 sine squared theta is minus 1. So sine squared theta is minus 1 over minus 5. Sine squared theta is 1 over 5. So sine theta is square root of 1 over 5. Now remember, whenever you find the square root of a number, sine theta is square root of 1 over 5. Sine theta minus the square root of 1 over 5. Sine is positive in quadrant 1 and quadrant 2. Sine is negative in 3 and 4. Right. So, going to do something here. Someone tell me why this one does not matter. Tell me why this one doesn't matter. It's supposed to matter, but something in the question tells me I don't need to worry with that one.
The boundary is 0.
Correct. Very good. Very right. This here is only between 0 and pi, which is only quadrant 1 and quadrant 2. So I could do sine theta r is root 1 over 5. Theta r sine inverse root 1 over 5, which is 0.46. So therefore, theta is 0.46 and pi minus 0.46. 2.67, but I must listen to what the question say, one decimal place. So that is 0.5 and 2.7. Right now, in your calculator, sometimes it might give a different answer. So just for safety purposes, round off the 2 decimal places and show them why you get the 0.4, the 0.5 and 0.7, right? Just do that, right? So they'll see that because I'm sure some of you all probably got 0.44, so you'll round off to 0.4 and 0.64 to that round off to 0.7. Oh yeah, my calculator off. So you're supposed to get what? 0.4 and 2.6, eh? Yeah, my calculator off. Yeah. You can. Oh, okay. So small a bit. So sine squared theta is 1 over 5. Sine theta is the square root of 1 over 5. So it's either plus or minus. Now, because it's negative in the third and fourth quadrant, we cancel that out. We go for 1 and 2. Theta r is sine inverse of root 1 over 5, which you'll get 0.46. Because it is in quadrant 1 and quadrant 2, that would be theta r and pi minus theta r, which is I still get the 0.46, which would be 0.46. So that's 0.5 because you have to round off to 1 decimal place. And pi minus 0.5 is 2.6. So you're getting So you're getting 0.44. All right, cool. So I got 0.44, right? So that's fine. So 0.4, and we ignore the negative, right? Because we ignore the negative because it's only between the range that they gave you is between 0 and pi. And quadrant 3, remember, is pi to 3 pi over 2, so that exceeds the pi. And 3 pi over 2 to 2 pi, that also exceeds the pi range that they gave us. All right, let's look at the proof now. Everyone hates proofs. I would personally start with the left-hand side. Right, you get 27 because your thing is in degrees, not radians. Right, so start with the left-hand side, see what you could come up with. Correct, yeah? So you have to find the LCM. All right. So with this one, right? As I said, sorry, left hand side. So left hand side. 1 over 1 minus sine x minus 1 over 1 plus sine x. Find the LCM. It's a horrible fraction now. 1 minus sine x, 1 plus sine x. You would get 1 plus sine x minus 1 minus sine x. How do I get that? 1 minus sine x into this is 1 plus sine x. 1 plus sine x into this gives me 1 minus sine x. So you get 1 plus sine x minus 1 plus sine x over a minus b by a plus b is a squared minus b squared. 1 squared minus sine squared x. So I'll get 2 sine x over 1 minus sine squared x is, so I know sine squared x plus cos squared x is 1. So cos squared x, 1 minus sine squared x. So I'll get cos squared x below. Now here's the issue. Look at my, so this is as far as I could go. What can I do? I see in here, this is only cos x. So I'm actually going to break it down, right? I'm going to get 2 sine x over cos x, cos x. Why am I doing that? Because when I look at my goal here, I need cos x below. Let me see if I could separate it. I'll get 2 sine x over cos x into 1 over cos x. Sine x over cos x is tan x by 1 over cos x. Tan x, well, 2 tan x over cos x. So let me show you the thought process again. I find the LCM. Once I find the LCM, I get my 1 squared minus sine squared x below, 1 plus sine x minus 1. Minus by minus gives me a plus. Next thing you have to do, you get 2 sine x over cos squared x. 2 sine x. Now, I need to get cos x alone. So I'm going to say, I'll split it up, right? So I'll get 2 sine x cos over cos x by 1 over cos x. Sine x over cos x is tan x. I know I wanted to get the tan x, right? By 1 over cos x. So I get 2 tan x over cos x. All right. Okay, so let's see here. I think so. You all could do the rest of traits, right? So we're going on to logs. I just I can find the log question that from everybody. Right. So log rules. 1. Log a of x plus log a of y is log a xy. 2. Log a of x minus log a of y is log a x over y. 3. Y log a of x is log a x to the y. 4. Log a of a is 1. 5. Log a of 1 is 0. 6. To convert any number to a log, we multiply by log a of a. So for example, 2 is the same as 2 log 5 of 5. So if I want to do that, I could do that, right? So some of y'all know how to do the switcheroo thing. Nah, right? If you know how to do that, great. This is the simpler way I just do it. Just multiply by log a of a, right? I think that's, for me, that's the easier way, right? If you all know how to switch it based on whatnot, by all means. Anything else you want me to know? Yeah. 7 cannot have log a of x, where a or x is less than or equal to 0. Right, so you can have log of 0, you can have log of -1, and so on. 8 LG or log without a base is log to base 10. Then these are the only rules you really need, right? So we're going to do a couple log questions. So I'm going to go till about 7:15. If you have to leave, by all means go, right? I know holding it back, especially those who do in bio. Again, bio or Spanish, right? So yeah. All right. So let's try this one. See what you could come up for this one. That log 10 is a men thought it was a log 2 of 10 and worked it like that. No, don't do that, right? Right. So log 2, when you minus, you'll get 6 plus root 12 over 3 plus root e is 1. Log of 10 is 1. Log a of a is 1. So now I need to convert this. Log 2, 6 plus root 12 over 3 plus root a is 1 log 2 of 2. Log 2, 6 plus root 12 log 2 of 2. Oh, I forgot the most important rule. That is what? No, it has 9. If log a of x equal to log a of y, then x equal to y. Forgot that one.
Siri, you could just use the indices thing.
Yeah, you could. If you understand the indices thing, by all means. But when I was teaching it,
Yeah.
the indices thing was a bit weird, so
Mm-hmm.
that's why I did, right? So I get 6 plus root 12 over 3 plus root a is 2. This cancels with this. So I get 6 plus root 12 is 2 to 3 plus root a. Six plus root 12, 6 plus 2 root a. This cancels with this. Root 12 is 2 root a. How do we get rid of a square sign? We square both sides. So I get 12 is 4a. 12 over 4 is 2. But 3. Right. So let me just repeat what I did there. Log 2, when you minus logs, you divide. Log 10 is 1. Then next, if you know how to do the indices thing, by all means, so you can do 2 to the 1 and so on. For me personally, anyway, I taught my class, right, would be take that to be log 2 of 2. Right? So you'll get 6 plus root 12, 3 plus root a, is log 2 of 2, cancel. 6 plus root 12 over 3 plus root a, cross multiply. 6 plus root 12 is 6 plus 2 root a. Now you could have square both sides if you wanted. You could do root 12 is square root of 4a. If you want to introduce it, 12 is 4a, a is 3. So if you did that as well, introduce the 2 into the SID, or you could have done root 12, 2 root a by 3 square root of, so that's what? 2 root 3 is 2 root a, so root 3 root a, so a is 3. So yeah, could have done it many ways, but same way to get, different ways to get the same answer, right? All right. Take this down. I want to try just 2 more, and then we'll call our class. Right, tomorrow.
Sorry.
Yeah,
Were you
go ahead,
gonna
go ahead.
send the recording of the class?
So as soon as it's finished, it should take what? About half an hour to process, and then a 15 minutes upload. So I would say by 9 o'clock, I'll send the link in the group. And well, you all
Alright.
could forward it.
Okay.
All right. So Let's try this one. All right, so this one. So let's bring everything in. So this is log 2 to the 3x plus log 8 to the x is 2 log 10. Log 2 to the 3x by 8 to the x log 10 squared. So we'll get log 2 to the 3x. We need to get this to the same base, right? So we'll get 8 is 2 cubed. 2 to the 3x is log of 100. Now, this question real annoying, right? So why I say it's annoying? You gotta do log and then log again. Or you could do this. 2 to the 3x is 2 to the 3x plus 3x is log of 100. So we'll get log 2 to the 6x is log of 100. So 6x log 2 is log of 100. I'll be saying, so you really take the longest way you could do this, eh? Yes, I did. But I did the longest way because this is probably the most 6 log 2, and you all will tell me the answer. Well, they'll just tell me in the chat, right? Or you could have done this. 3x log 2 plus, if I look here now, log 2 to the 3x is 2. So I get 3x log 2 plus 3x log 2 is 2. So I could get 6x log 2 is 2. So x is 2 over 6 log 2. To do that as well. There are many ways you could have solved it, but this is one of them. All right, so that'll be it for today's class, right? Now, so we covered trigs and logs. Let me see, 2, anytime I ask an advanced student, so so trigs and logs. So trigs, logs, so, right? So I covered the 2 main ones. Now tomorrow, I know some of y'all will not be here in bio and Spanish. That's fine. If you're here, great. If you're not here, just watch the recording, right? I'll post it up as soon as I could, right? Monday, we'll have our long class. Now, long class in the sense that you can join, you can leave, do whatever, right? Bio is in the morning. Sorry, it's a Q. CSEC timetable. Now, the only issue is, all right, let me just pause it. Wait, stop the recording.